First, we have the battery. Think of it as a power source for the train. It provides the electrical current that makes the train move. Next, we have the coiled copper wire. This wire is wrapped in a circular shape like a spring. It acts as a pathway for the electricity to flow through. Now, let's talk about the magnet. The magnet used in the train have a north pole and a south pole. This magnet plays a circular role in creating movement. Before we start our experiment, we need to check the function of magnet. So, we close up two magnets with same pole, and we can see it repel each other. Firstly, we need to put the magnet at negative terminal and positive terminal the battery. When we place the train inside the coil of copper wire, something interesting happened. The magnet on the battery touched the wire, completing a circuit. This allows the electricity to flow. As the electricity flows through the copper wire, it generates a magnetic field. Each loop of the wire contributes to creating a larger magnetic field. Here comes the exciting part. The magnetic field created by the wire interacts with the magnet. One side of the train is pushed away, while the other side is pulled forward. It is like a tug of war between the magnet and the magnetic field. This push and pull force of the magnet causes the train to move along the coil of the wire, creating forward motion. The train follows the path of the coiled wire.
2,000 years later.
Alright, Bismillahirrahmanirrahim. My name is Fahim and I will explain how the simple electric train move. Now, first thing first, this is our battery and this is the terminal, the negative terminal battery, and this is a positive terminal. Now, we will arrange the magnet and the the north pole of the magnet is on the inner side, and the south pole is on the outer side, and it will be on the both sides of battery. And this is our copper wire. Now we know when the magnets touch the copper wire, it will complete the closed circuit and induce an electrical current that flow only through a section of the wire. So, as you all know, the electron will move from negative to positive terminal. So, we also know that the current will go from the positive to the terminal negative, and from that we can see there is a thumbs up here. So what is the function of the thumbs up? So the thumbs up is not just a thumbs up. This is a rule in here. The name is right hand grip rule. So the thumb will be the indicator of current, and also if the current goes here, this will be the nose pole, and the other finger will show the magnetic field. So in this situation, we can see this will be the north, this will be the south, because of the current will be go from positive to the negative. And also we can see the magnetic field in this will go like this. So I will draw back the magnet. Okay, so we can see the nose magnet and the magnetic field will push or repel with themselves, and this south and north magnet, they will attract or pull with themselves. So because of that, the train will move to the right. That's all from me. Thank you.